The last thing that we need to review is stoichiometry. So far, we've dealt with calculations converting chemicals into other forms or expressions. However, we haven't really talked about reactions where chemicals are converted into other forms. In cases like those, we need to do stoichiometry to be able to accurately describe and imagine how the chemicals are converted into something else. Stoichiometry relies on a balanced chemical equation. Take a look at this example where small letters are corresponding the balanced coefficients and big letters correspond to the chemicals. If I want to convert grams of A into grams of D, I need to use this balanced chemical equation to perform stoichiometry. Again, we need to cancel out the units so that we are left with grams of D. So how do we do that? If we start with grams of A, we know that we can figure out the molar mass of A. So if we multiplied grams of A with 1 mole of A per certain grams of A, again this is 1 over molar mass, we are left with moles of A. Since the basis of stoichiometry is the relationship between moles and not grams, we can now relate moles of A to moles of D. Using the balanced chemical equation, I know that there are A moles of A for every D moles of D. And since I now have moles of D, I'll just multiply it with the molar mass. That's Y grams of D per 1 mole of D. This is just straight up the molar mass. If you look at this calculation, notice how everything cancels out cleanly: grams of A, moles of A, and moles of D. All we need to do is to apply and multiply all of the necessary values. Stoichiometry in concept is very simple because it follows a linear path. All you need to do is to figure out from the balanced chemical equation the set of steps necessary so that you can cancel out the units to get the unit that you want. In the analytical chemistry laboratory, however, it's not very often that we deal with grams and convert them to other grams. Because in the laboratory, it's much easier to handle solutions than pure solids. So, let's talk about an example dealing with solutions. What mass of silver carbonate is formed when 25 ml 0.2 molar silver nitrate is mixed with 50 ml of 0.08 molar sodium carbonate? Let's write down the given. Immediately, we are given with the molar mass of silver carbonate, 275.7 grams per mole. We're also given with 25 ml silver nitrate, and that's 0.2 molar, reacted with 50 ml of sodium carbonate, which is 0.0800 molar. I know that I need to do stoichiometry, so I need to include in the given the balanced chemical reaction. So I know that my reactants are silver nitrate and sodium carbonate, since they are the ones being mixed. I know that one of the products is silver carbonate. So that leaves the other product to be sodium nitrate. I'm not going to review how to balance a chemical equation anymore, but if you're already comfortable doing this, you should see that I need to multiply silver nitrate by 2, and then I need to multiply sodium nitrate by 2. And this should be the balanced chemical equation. When you are provided with a chemical equation in your problems, do not assume that they are already balanced. They might be there to trick you. So the first thing you should do, one of the first things you should do, is to double check that the equation is correctly balanced. We need to find the mass in grams of silver carbonate formed. Again, from my first discussion, I should use A or B to get to the product C or D. In this case, we are given two reactants. So let's say silver nitrate is A and sodium carbonate is B. Which one of these two should I use for the calculation? Well, I need to use the one that gets used up completely. We call that, if you could recall, the limiting reactant or the limiting reagent. One chemical, either silver nitrate or sodium carbonate, is too much or in excess, so that not all of that value will be used up, while the limiting reactant is used up completely. So we need to find out what the limiting reactant is first. To do that, I want to calculate the moles of silver nitrate. Since I'm dealing with ml, I'll use millimoles. 25 ml of 0.2 molar silver nitrate is 5 millimoles. This isn't the final result yet, so I'm foregoing my significant digits. On the case of sodium carbonate, I have 50 ml of 0.08 molar. To compare silver nitrate and sodium carbonate, they must be of the same species. 5 millimoles corresponds to silver nitrate. So, if I want to compare silver nitrate and sodium carbonate, I want to express them in the same form. I already expressed silver nitrate as silver nitrate. So I'll use the balanced chemical equation to convert sodium carbonate to silver nitrate. I know from the balanced chemical equation that there is 1 millimole of sodium carbonate for every 2 millimoles of silver nitrate. That corresponds to 50 times 0.08 times 2, 8 millimoles. Which among silver nitrate and sodium carbonate then is the limiting reactant? If you compare the two values, it becomes clear that there are less silver nitrate compared to sodium carbonate. Okay, I converted them both to silver nitrate so it's easier for me to see, but in the presentation that both of them are silver nitrate has less moles to react compared to sodium carbonate. So, silver nitrate is our limiting reactant. We will be using the values for silver nitrate for our calculation. Let's move on. I know that I will use 25 ml of 0.2 molar. So 25 ml of 0.200 molar, that's millimoles per ml of silver nitrate cancels out the ml, and since I need to get to silver carbonate, I need to apply the stoichiometric factor. In this case, there are 2 silver nitrate for every 1 silver carbonate. So, 2 millimole of silver nitrate for every 1 millimole of silver carbonate. And to complete the solution, I need to cancel out millimole. Silver carbonate is 275.7 grams per mole. I'll multiply this by 275.7 milligrams per millimole of silver carbonate, and I cancel out everything else except milligram silver carbonate. I'll just convert this into grams, and the final answer should be 0.68925 grams, reducing that with the appropriate significant figures, which is 3. The final answer is 0.689 grams of silver carbonate. I hope you were able to refresh your memory on stoichiometry, and don't worry if you didn't get it this time around. There should be some opportunity for you to catch up using our non-graded formative assessments. This has been Le, and I will see you soon.